All right, just started that. All right, so to introduce myself, my name is PJ Bennett. I am the director of the Denver lab of the North American Network of Science Labs Online, which is currently our largest lab. And I thought I would start with sort of our philosophy, which we have taken as to expand the accessibility of distance science education through remote access to high-quality laboratory equipment and activities. One of the biggest problems we run into here at the Colorado Community College, and I'm sure you run into there as well, is students wanting to complete certificates or AA degrees, but having difficulty on an online environment getting laboratory classes. So that's what we're trying to help facilitate. We have just recently, let me turn that off for a second. Created a video I wanted to start with.
NANSLO is a network of science laboratories with
Can you hear the video?
that has all been internet enabled so that students can access laboratory equipment from wherever.
You need to go a little louder on your side if you can, please.
It's a little. NANSLO is a network of science laboratories with exceptional equipment that has all been internet enabled so that students can access laboratory equipment from wherever they are in the world with a standard internet connection.
It's different from a simulated lab because you're actually physically making the equipment move. You're seeing the results. This allows other institutions to log in remotely and actually manipulate the labs.
So you have students from all different locations logging into the lab equipment at one time, and they get to talk to each other. They each get to see what each other is seeing, and they get to discuss the results of their experiment.
Give students the opportunity to use real high-end laboratory equipment to do real collaborative experimentation. That is a game changer for online science education.
The students can log in at times that are more convenient for them. They can do it from their home or from their work. It also allows them to be able to take pictures of what they see and being able to see them at a higher magnification.
Students have the ability to interact with high-tech equipment that they're more likely to see when they get into the workforce.
The huge advantage is the access to this lab equipment that you otherwise would not have. This gives you high-resolution microscopy where you can change magnification, move your slide around, and if you look at high-tech microscopes that are being marketed, that's what they're doing. They're doing it all from your computer.
That's really the kind of scientific experience we want students to have. The physical infrastructure required to build labs on campus is significant. And so NANSLO offers an alternative that is a shared facility across multiple institutions and can be a shared cost and a shared revenue generator across multiple institutions.
So even though a college might not be able to afford the equipment, their students and their faculty still have access to that equipment.
I really do believe that this is the way that we're going to be doing both face-to-face and online science labs in the future.
It gets the student engaged in doing science.
From a faculty standpoint, I think it really gives the students that critical thinking piece that you don't always get in a face-to-face lab.
This gives them an opportunity to acquire the degrees they want without having to travel. It removes some barriers for students being able to achieve what their goals are as far as career choices.
We're just going to have to find ways in which the institutions can provide high-quality lab experiments at lower cost. And NANSLO is the kind of program that can provide it.
So there's a brief little introduction to NANSLO in a nutshell. These are our three labs. The original lab is in North Island College in British Columbia, Canada. The second lab, which was founded in 2011, is here in Colorado, and our third lab is in Great Falls, Montana, and was founded in 2014. So this is sort of the idea behind our approach. So this confocal microscope is run by a computer, And in fact, this particular model you couldn't even run by hand if you wanted to. And the question then becomes, once something is run by a computer, what's the difference between a meter versus 1,000 kilometers? And with our current technology, there really isn't much of a one. We design our approaches with sort of two foundational points. Whatever happens with the equipment the student sees and controls, and we're using high precision instrumentation for inquiry-based activities. So as you saw in the video, here's a photograph of one of our microscope setups, and then you can see on the computer screen here next to it, the student is seeing exactly the same images as appearing on the microscope, and they can move that image around, zoom in, focus on it, and those sort of things, and I'll demonstrate some of that in just a little bit. And another way to look at this is anybody that's done biology, and in some cases chemistry as well, has seen this particular experiment, the classic semi-impermeable membrane diffusion experiment with iodine and starch. You put the starch in the bag, you drop the bag in a container of iodine, the iodine diffuses in, the starch changes color. Well, this is of course a Brownian motion mediated sort of principle, random motion of molecules, and that's highly dependent on temperature. So you can change the rates and what's going on by changing the temperature. And sort of here's what you get if you try to do this experiment using the little dialysis bags. Okay, maybe I see a difference between some of those bags, maybe not. All I can really say is, well, it looks like, the one at 40 degrees gets darker faster. So the traditional approach, we've made a very simple change, which is using these little dialysis caps. There's a little tiny dialysis membrane in the bottom of it. We fill the cuvette with either starch or iodine. We allow the students to do it in both directions, so they can see in one direction you will get diffusion out into the cuvette, and the other you don't. And then you put starch or iodine in the top, and here's what our data looks like. So now you can do analytics things, look at the actual differences in rate reactions, things like that. It gives us the ability to have the students do real graphing, real mathematical analysis, and you can see there's this one red dot that sort of doesn't follow the line of everything else. And again, they're doing real experiments with real instrumentation. Occasionally you'll get one of those little aberrant numbers with real instrumentation. That's one of the differences between using real equipment versus simulations. You get the real variability of an experiment or instrumentation. Here's one of our experimental interfaces. All of our interfaces follow the same basic idea, in which you have a video screen on one side and instrument controls on the other. And if you need more than one, there's tabs up here that allow the students to switch back and forth between the different instruments. We have a button here that lets them join the voice conference. In this particular case, because it's a microscope thing, they can view the image they've captured. There's an image capture button right here. We do have a short survey that we run, so they can take that short survey, and in the event that they need to, they can just simply reload the page rather than going back out and logging back in if something happens to their setup of their system. We currently have about 40 lab activities available. Sorry, that was not how I actually wanted them to display up. We have, so these are our biology experiments. A good chunk of these are using the microscope, though a few of them buffers, membrane diffusion, use different setups. Buffers uses a titration setup, membrane diffusion uses our spectrophotometer, as does enzyme kinetics. And we have a photosynthesis experiment that uses CO2 and oxygen probes to measure the production and consumption of oxygen and CO2. For chemistry, we have a number of experiments that use different sorts of things. A lot of these are titration or spectrophotometer experiments. We also have the electron charge to mass ratio using a Helmholtz coil, and we do have a nonpolar gas chromatograph that we can use. And then our physics experiments. The ones with asterisks are currently only run out of the Canadian node. But if needed be, I could get most of those set up down here in Colorado as well. So these are our
quick question for you. Are the lab equally available to our students, or is there a differentiation between the Canadian and Montana and Colorado?
Everything on this list except for the ones with asterisks I can run right now.
But if an instructor needed one of the ones that's only available through the Canadian mode, is that available to,
yes.
To a subscribing school?
Yes.
Okay.
You could either use Canada, or I could go through the process of getting it set up down here in Denver if for some reason that was more convenient.
Okay. Thanks.
These are our lab techs. I just wanted to put them up to remind myself to talk a little bit about how they work and what we do. So whenever the students are online running a lab, we have actual lab techs physically present here in the lab who are here mostly in case there's a technical problem. You know, we don't want the students to not be able to complete their lab because somebody just needs to turn off and on a switch. You know, we have a lot of moving parts occasionally. Some things bind up a little bit. But they also, you know, help the students stay on track, remind them of what time it is, answer basic questions. They don't do specific instruction because we want to leave that to the instructors themselves. And the students actually really like having somebody here. It's sort of like a warm blanket. They know if something happens, they have somebody there that can help them get through it, even though for a lot of the interactions, the lab techs will come in and say, hi, you know, like for instance, my name is Zach, I'll be your lab tech, let's go ahead and get everybody started. And that may be the last interaction they have with them for the whole lab period, because the students come in, they're prepared, they're ready to go, they work as a group, and they get their experiment done and they leave. Now, the interesting part. Let me change out here. So looks like you should be able to see that. This is the interface for our microscope. I do currently have one of our microscopes up and running. And this is the way it looks when the students first log in to do a experiment. We have this little sign up here that reminds them to click the voice conference. So we can have anywhere from 1 to 5 students on simultaneously, and that number is actually settable by the instructor depending on what they want to do. Technically, we can actually go all the way up to 10 students, but for pedagogical reasons, we just don't think that's a very viable number. So we limit it to 5 at this moment in time. As I said, the students get to control everything. I think I may actually have control of this, yes. So in order to control the panel, the students do right-click, or if you're on a Mac, control-click or 2-finger click on the touchpad, and that gives them control of the interface. And once they have that, they can start controlling things, moving the camera around, setting presets that lets them view different things. And we often encourage them when they very first log in to, you know, poke at the settings and controls and look around, or as they like to do sometimes, we called it, you know, find the lab tech. They can pan the cameras all the way around the lab. So for instance, I can show you. There I am sitting at my desk. And then they have the controls for the microscope, and in order to load a slide, they go over to the slide loader, they would select the slide they're interested in loading. In this case, let's take the Elodia leaf, and they click the load button, and then you'll see the arm will move. First, the stage slides over, the arm moves, grabs a slide. And it comes back. One of the other things that the exterior camera is very good for is it allows you to zoom in and the magnification is good enough that I can get right in there on that slide and see what I'm doing. When I go back to the microscope controls and I start moving it around, I can see, oops, I seem to be moving in the wrong direction. Let's move back the other way. And now that I found my sample, I can go in and I can turn that picture. Yes.
I've got about a 3x4 of the actual slide now. If I had control of this, would I be able to, how much of my screen territory could I expand this to?
The interface is probably, my guess is you have a larger monitor, it's probably about the way it is. It doesn't expand very well, and we're using this particular size because a lot of our students still have smaller screens.
Okay.
And we don't want them to have to do a lot of scrolling.
I was just going to say the same kind of thing. It seems like the view of, you know, looking around the lab or looking at something is really small.
In this particular instrumentation setup, we decided to make the primary camera the camera that is attached to the microscopes because we thought the most important thing for the students to be able to see was the stuff that's on the stage itself. In some of our other setups, the camera that looks around the lab will actually be the same size as the one that the microscope image is in.
Okay.
We have been thinking about trying to change this over so that we would flip back and forth between full views as well if the students, if we thought it would be a better view for the students, but we haven't actually done that programming yet.
So PJ, so just to clarify, so I'm looking also, and so in our WebEx meeting, the screen for the NANSLO is maybe a quarter to the third of the WebEx meeting screen?
Yeah, that's because I have the interface on my large monitor.
Okay, so on a normal basis, though, then it would be larger than what we're seeing through the WebEx. Is that correct?
It would probably fill more of the monitor.
Okay, okay.
I mean, like I said, we haven't made this interface as big as we possibly could just because we have a lot of students that have smaller, still are having smaller monitors or access through laptops. We also have access to focus, so I can focus up and down, and I can change the step size by changing the coarse or fine button. And then I can increase magnification. And then to demonstrate what we have also available for the students, when they're doing experiments, they can now come in and capture an image. This will take just a moment. And once they've captured that image, they have the option to view in a much higher resolution picture. So this is the picture that they can save and use in their lab reports for annotations and things like that.
I'm going to jump in here with a question for my faculty member. George, what do you think about the clarity of that image? How does that compare? Oh.
I could focus a little better.
I don't know if you heard that question, George. I'm just wondering if you can give me a sense of how this might compare to what students would see in either at home or in their textbook or on the web.
There I was talking and muted. Sorry. You know, it's very similar to what they would see in those environments. You know, I guess it's nice that they can see the actual big microscope and have a sense of interacting with it, but I think the images are going to be very similar. I use, actually for histology now, I use mostly web-based images because students doing their own preps, especially for general biology, you know, they don't get an image like that at all.
I just saw that warning come up. Got to ask a question. Am I able to break the slide like I did so many times when I was in 7th grade at home?
You, in fact, can. And we have had students that have done it. That's actually why we have the little warning. And one thing that I will mention, I don't know if this will be of interest to you, but sometime in the next couple of months, I am actually going to be adding fluorescence and phase contrast functions to these microscopes as well.
Now I have a question. Do they actually get to have the experience of prepping their wet mounts or prepping their slides for different staining techniques and that kind of stuff, or is it purely choosing slides and looking at pre-prepped slides?
Currently, we are using mostly pre-prep slides. One of the things that we are interested in the future is working out a system by which students will be able to send in slides and we can have them available for use.
Right, because that's kind of the thing, I think, you know, one of the biggest things with the lab experience, if we're going to go virtual, they lose that. I kind of like the hybrid where they're, you know, at-home sort of labs because they still get the wet prep experience.
Right, and that's a very relevant concern and question. And one of the things
I don't mind all virtual. I'm really open-minded to all virtual, you know, but I'd like to get to a point where students are getting the real experience, and I don't know how it happens yet. I see it coming in the future, but I don't.
So
it depends on the level of lab too, you know.
Yeah. The biggest problem that we're currently running into with trying to think through how to do this, we've been thinking about this for a little while now, is the question of how do we make sure that the student slides are available in the lab section that they're signed up for.
Exactly.
You know,
that's another question I have is how is this, I actually have to go virtual. I mean, I have to hit the road. I'm going to be on the iPad instead, but I wanted to be sure and get that kind of question in, and if you can show us sort of how a lab works, whether they're synchronous or asynchronous, and what if one student's using the big scope and another student wants to use it for something else, or do they have to come to the same lab and put the same slide on the scope?
Yeah, so the way that we've worked it out right now is we generally make a lab activity available for a week at a time, just because that correlates with how people usually run them in face-to-face courses, but we could modify that time period. And during that week, we will have specific time slots. So say, for instance, one of our microscope labs takes 2 hours. We'll have 2-hour blocks. My lab runs generally from 4 to midnight. And the students would sign up for a 2-hour block, and they'd come in, and whatever other students are signed up on that experiment all come in together. They have a voice conference that they join so that they can talk to each other, and then only one student at a time can control the microscope, but they can transfer control to another student, and we have that written into our procedures, things like, okay, now, you know, change to another student, and, collect another data set. And for instance, our lab techs also sort of watch that kind of thing. And if they notice the students in the background, we've come up with some little scripts, things like, oh, hi, John, I see that you're not really doing anything. Is your internet connection okay? Why don't you, test that out and take control of the interface for a second and collect some data and make sure everything's working. To try to keep all of that in case. And we also have a mechanism built in whereby the lab techs can enter in comments of things that they've observed, and those comments can get sent back to the instructor so they can see from their students. And of course, instructors are always welcome to log in and see how things are going with their students at any time as well. And so we have a scheduler in the cloud, and what happens is the students get a URL link and a PIN, and they use those to schedule a date and time. That URL tells the scheduler which activity the students are signing up for. And then they pick a date and time, log in at that date and time, and do it. So everything is in real time. And we were very active about this collaborative approach because that's something students in distant courses doing things like lab kits don't often get. They're often working by themselves in their own home. So this allows the students to work together similar to what they would be doing in a real face-to-face environment.
So it's, in a sense, it's synchronous, but they sign up for their time slot?
Correct.
Okay.
Yeah, since they're running real equipment, the synchronous helps. And yes,
yeah,
I do.
I mean, obviously.
Yeah.
Go ahead.
And I do understand what you're talking about with, the actual staining of slides and stuff like that. Like I said, that's something we're thinking about. Here is an interface. You should be seeing a slightly different. That is for our spectrophotometer setup. And there are several things in here that the students use. The black box in the center is actually a temperature controllable rotary cuvette holder that holds 6 cuvettes, so the students can select which cuvette they use. The 2 red boxes in the back are syringe pumps, so the students can select which solutions they're entering in or make their own dilutions. So for instance, for our Beers Law Lab, when they have to create their standard curve, we basically just say, here's your standard at this concentration, here's your water to dilute it with, make your calculations, decide what dilutions you want to make, and then the last cuvette in the system is their unknown that they have to calculate that with. So while they're not physically mixing it with their own hands in their house, they are making up their own standards, and they still have to do the same math that they would do if they were doing it, with their own hands in a face-to-face environment. They have all of the functions available to them that they would if they were doing this in real time. So right-click, request control, and I can start my graph. Everything's nice and flat, so I can store my dark reference, turn on my light, store that reference, activate my absorbance spec, rescale it, and enable my cursor. And this cursor now tells me what the absorbance is at any position along the graph. I can also change the number of spectra to average.
Sorry, I'm just going mobile now. I didn't really leave.
Okay. And change the boxcar as well if they would like. And you'll actually see a slightly different interface here with the graph. So we're in the process of modifying how the students save data in it. Historically, the students have saved data by copying and pasting to their clipboard or right-clicking and saving interfaces. That has actually proved to be a little bit of a problem with some students and some older machines, as well as the fact that in order to do that, you have to have the Citrix receiver installed on your machine, and the Citrix receiver doesn't work with Chromebooks. And there's a lot of students that are starting to go that route now. So what we've done is we've built a modification that allows the students to save the data. They can enter, whatever name they want, whether they want the image or the data, and then export it. That saves it to a database, and then at the end of their lab, they can enter an email address into another little application, and that data will just be emailed to them instead of copying and pasting it. Our cuvette holders are temperature controlled, so I can turn on the temperature. I can turn on stirring. There's little stir bars in the bottom of each one. I can set what my temperature wants to be, so if I want it to be like 35, and we have a graph that shows what that temperature is. Cuvette controls and volume additions. So let me zoom in a little bit here so you can see. Now when I go in and change the cuvette, you can see that it changes. And I have pump 1 with water, so I can say I would like to add 2 mils of water. And I click add. It's a little hard to see on the screen, but it just, little tiny stream comes out of that needle there. And I can change to pump 2. We only have 2 pumps hooked up right now, but we could actually run as many as 100 if we really wanted to. As you can see, 4 mils fills it right on up to the top. I can jump back to my spectrometer now. And you can see I have a nice absorbance peak that I can look at. We do have the options of a value log as well if the students are doing an experiment, like for instance our enzymes lab, where the students will go through, set up things, and then they can just set the machine to collect data every so many minutes or seconds that they wish and for a length of time, and then just run a data collection. Does anyone have any questions?
This is Karen. I
think that I got all of mine.
Describe a little bit. Oh, I was just going to ask if you could describe what is provided to the instructor regarding the labs. I know there's a list of labs, but what is provided to the student and the instructor, and what kinds of support materials or those kinds of things accompany this?
So we have complete procedures written for every single one of those activities I showed you the list of. The procedures are written to be independent of any course or textbook, so everything the students should need to conduct the activity should be in that procedure. They are all Creative Commons open source licensed, so they can be modified by the instructors in any way they wish. Any basic modifications we don't even really care about. The only modifications that we would need to know about is if you wanted to use a different sample than what was actually written in the procedure, so that we'd make sure that we had it available when those activities were taking place. We also have we have a website for students that have various videos that they can look at that runs them through. Here's how you control the interfaces in the equipment. We're making a few more for things like here's how you schedule a lab and things like that. Historically, that's been another member of the project, but we're starting to try to collaborate everything into one central location. We have a few tutorial documents that give some basic information on how to use the equipment as well. I personally act as escalated tech support for any tech problems, so anytime the students have a problem, they could simply call directly into the lab. If the lab techs can't solve it, the lab techs will put them directly in touch with me during the actual lab periods. I'm in the process of building out a troubleshooting page on our website. but I don't quite have that done yet. And our home page just goes through the installation of the Citrix receiver, though the nice thing about that is once we get all of the procedures modified to use the new database save method for data, the Citrix receiver will no longer be necessary. We'll be able to access directly through what's called an HTML5 interface. So any modern web browser will be able to access the interface without any additional plugins or installations.
And so, you know, a lot of our students are up in the mountains and those kinds of things. Have you seen any issues with the type of computers they have, or their location, or storms or anything during a lab time? And do you report if there is a breakdown, power outage or something, is that reported to the instructors so that they're aware that there may have been an interruption in the lab, maybe that was due or something?
Yes. So let me I don't have it quite here on this computer yet. Just in the process of setting up my new laptop. We do have an interface that the lab techs log into, and it shows them all of the students that are logged on, all of the students that are going to be logged on for that evening. And there's places in there for the lab techs to enter in comments. So if there was a power failure or some major technical problem, they would enter that as a comment in the students' records, and those records then get passed back on to the instructor so the instructor knows. Sometimes if something is particularly unique, I'll reach out to the instructor individually for a particular student and say, hey, we had this student that had this problem. Here's a couple of options that we can do to try to solve it. Let me know which one you would like to do. As far as network connections, we actually are able to maintain network connections down to fairly low network speeds, even down to what would be equivalent to probably the 28.8 dial-up modems. We have a particular hardware device in our setup. It's one of the reasons we went with Citrix that's called a NetScaler. And what a NetScaler does is it monitors and balances network connections. So it tries to optimize those network connections. One of the biggest problems with slow network connections is that you occasionally get little tiny gaps in the signal. And a lot of systems, when they hit that gap, they'll view it as a disconnect, and so they disconnect the student. The NetScaler prevents that from happening. With the NetScaler, those little gaps are simply ignored and the connection is maintained until an active disconnect is run into the system. So we've been able to get students on with quite slow network connections. The only two computer problems that we've really run into right now are the Chromebooks, because there's not a very good Citrix receiver for that one. But as I said, we're doing a programming workaround, and that should be finished in probably the next 2 or 3 weeks. And so the Chromebooks will be able to work just fine after that. And then Windows XP machines, because it turns out that Windows XP was incompatible with the Citrix receiver because they'd stopped supporting it. But again, this workaround should solve that problem if we run into those students again, because it'll be an HTML5 connection after that.
PJ, with that HTML5 connection, does that allow the cut and paste, or everybody would be doing the database?
Everybody would be doing the database. In fact, that's the reason we weren't using HTML5 at first, because of the way security is run in HTML5 interfaces. The notepad and the save functions on a student's computers are not available through it. So we had to find a workaround for that, which is what the whole database design was for.
And with that, then you eliminate the need for the downloading the launch program?
Correct.
Just straight connection through the web?
Yep. The connection is still run through the web. It just doesn't require the students to install a app on their own machine.
Gotcha. Okay.
So I'm sorry, I might have missed that because I was out of sound for a moment, but so the students are working in the same database, entering their data?
The database, each student, the data will be saved for the group of students. So say there's 3 students online, microscope A at 2 p.m. That's where the data will be saved in that thing, and those students only have access to that chunk of data.
Okay, and so I'm just trying to get my head around sort of how it works working in a lab group together, but from different places and synchronously, or they have their lab like the lab written up directions to it, right?
Correct.
And someone is physically in the lab to get them started.
Yep.
And then they're sort of on their own reading through what should happen in the lab, or is there sort of a mini lecture up front by one of the lab people?
That varies based on the way the group is. Some groups will come in, and if they've done their pre-labs and stuff like that, they'll know exactly what they need to do, where to go,
Okay.
how to do it. If they haven't, the lab techs will often spend a little bit of time. Okay, here's where this is. Here's where this is. Here's the little things. And if they run into a problem or they get confused somewhere, they can holler at and go, I have a question, and the lab tech can try to help them through it and that sort of thing. And they're going to be all of them will be on a voice conference just like we are now.
Right.
So,
Right.
We'll see things like, for instance, we'll have one student that'll be controlling the interface, and another student will be going, okay, now the procedure says, and those roles change as the students rotate through who's controlling the interface and things like that.
Okay. So are they given those roles, and does it say?
The only thing our procedures will say is at particular steps through the procedures, we have notations that basically say, you should change who's controlling the interface now, and then the next student should collect a set of data.
Okay, nice. That makes sense. Thank you.
Uh-huh.
So PJ, this is Karen again. So when thinking about costs, is it the same cost per student no matter how many students are conducting a particular lab? And what kind of cost points are we looking at? Are they all labs the same?
At this particular moment in time, that has been the model that we have been thinking of. Yeah, some equipment is obviously much more expensive than others, so there's going to be some that we figure we won't recover it per student, and others that we'll get a little bit more back from. We're looking at right now, and this is something that is still a little bit in flux because we're just starting to develop this cost model. One option is sort of a by student hour approach, in which I think we're currently looking at roughly like $8.50 per hour, which roughly correlates in a number of the cases to the cost of a lab kit. A number of our labs are about 2 hours long. We also have the model in which we've been looking at setting a set fee in which you would say, I'll pay X dollars per student, and that gives you access to 3 labs or 4 labs or something like that, or just sort of a flat rate for a class, as it were. Some of the ways we've been talking with different people about paying for it is this institution's either setting up a fee, us trying to do a collaboration with a lab kit. The students would buy the lab kit just like they normally do, and then the lab kits would reimburse us for our percentage of it, or selling the access directly through the bookstores. And we've certainly also talked about the issues of trying to find ways to keep costs down for early pilots and sort of not charge full costs for schools, just sort of testing things out at first. Which is, I think, where sort of the flat fee approach comes in,
Right. One more question for me. So since you work so closely with the Colorado Community College system, are the labs written and specifically tied to competencies, and is that highlighted and outlined in the labs or for the instructors and those kinds of things, so that maybe it's really clear? And is there a way to maybe put some sort of access point in an LMS such as Canvas, or is it all a separate login?
So far, we don't do access through LMS. I'm not entirely sure it's impossible, but it's not something that we have done yet. There's been some concerns within the CCC Online of trying to do something like that because we work with more than one institution. So we haven't invested a lot of time in looking into whether or not we can really do direct access through an LMS. Certainly the pins and the links that allow the students to sign up and things like that can be placed inside the LMS, and that is actually what we currently do with CCC Online. The way our procedures have been developed is we actually have just been taking the approach that we're sort of a service organization, so we simply get requests from schools or faculty. I want a lab that fulfills these particular lab goals, and that is what we develop and do. We don't currently have them directly associated with competencies, but that is probably something that we could do and probably should look into.
Okay, thanks. Any other questions, Cheryl? George?
No, I think I've got all of mine covered. Thank you.
I'm good here. Thank you.
Okay.
Okay, well, thank you so much, PJ, for putting this on for us. It was good to see the lab experience, and I appreciate you doing this. So we will be connecting with each other here at CMC. Will you be sending me the recording through an email, the link?
Yes.
Okay, so I'll send it out to those folks who weren't able to attend, and hopefully they'll have a chance to take a look at it.
Yep, sounds good.
I guess I do have one question.
Yeah, thank you, PJ, for showing us around. Sorry, go ahead, Daryl.
PJ, the list of experiments in those subject areas, is that something that's available off the website, or can you send the deck to Karen or both?
I can send that list of websites to, or that list to Karen. There is a website out there, but we've just finished adding a couple more to it, so I don't think it's quite up to date yet.
Okay, that'd be great. Thank you.
That'd be great. Thank you.
I can do that.
All right, well, thank you,
Excellent.
PJ.
Thanks so much. I'll look for that email.
Yep. Thank you all, and have a good day.
Thank you. Have a good day.
Bye.